Good to go? Okay. Good morning. So my name is Philippe Paquet, and you're at the talk Harvesting Password from Source Code, Script and Code Repositories. We have 10 minutes at the end for question and answer. Presentation and tools are going to be available on GitHub. I don't have them on GitHub right now, but by this weekend I promise you that everything is going to be there. So why is this talk? I've been stumbling on passwords in source code very, very regularly and getting some amount of frustration about it. And because I'm curious by nature, I started to dig in that area. And I found a lot more than I was expecting. You know, I was expecting to find in some repository just a few passwords, some credentials, and what I found was actually very impressive. If you want to own a desktop network, you're going after the domain controller. If you want to own the data center, go after the code repository. Everything is there. To illustrate the issue, let's see what we can find on GitHub. Couple of considerations. So what you're going to see is that was done in the last 6 months. So because of that, if you do the search today, you're going to find different things. The same result can be replicated in about every kind of public source code repository. And I specifically avoided to search for generic broad term just because of the sheer volume of information there. So to be able to deal with that volume, you need tools, and we're going to talk about that later. So when you're doing just a search on GitHub, only the default branch is considered. So if someone is branching and putting some password there, you're not going to see it. If it's a very large file, you're not going to see it. So there's a lot more that you can find that simple search are going to show. One way to search on GitHub without actually using GitHub is just to use a search engine like Google. You just need to restrict the domain to the GitHub raw content domain, and you're going to be able to search with expressions that are a lot more sophisticated than what GitHub is going to provide you. So let's start with Authorize.net. Authorize.net is a payment processor. If you look at their sample code, I've got some sample code there. You can find some keywords: API logging ID, transaction key, MD5 settings. So a simple search for transaction key, API logging ID, and MD5 settings actually give you a bit more than 1100 results, and that gives you 31 valid set of credentials. That's kind of a problem if you have your payment processor credential available on the public internet. You could process payment, of course, but you could maybe process negative payment or do a purchase and refund yourself after. Shodan HQ. Shodan is an interesting example because it's a tool really geared towards the security community. It's a search engine that allows you to search in HTTP headers. So what that allows you is to find devices on the internet, identify devices. If you want to search for a specific brand of router, you can use Shodan for that. Because that's geared towards the security community, you would expect that the results are a lot better. Their sample code as a keyword, Shodan API key. So let's search for that. And we only find 114 results, but we still find 15 valid keys. So the results for a tool geared towards the security community are about the same as something very sensitive geared towards the general public. One anecdote is that if you search for that keyword, you're also going to find the hacking team Shodan key because their source code was leaked and put on GitHub. Amazon Web Services. Amazon Web Services, as most of you are familiar with, it's an infrastructure provider. What they have as particular is that their API key starts with AKIAI. So if you just search AKI, you get 100 code result, you get 2 valid keys, and you get something kind of interesting. You get people trying to hide their Amazon key in public source code by breaking the key in part. The only problem with that technique is that the characteristic part of the key was kept intact. So that's very inefficient. Don't do that. We can check for default password. Default passwords are very interesting. Most of the time, they don't get changed. If you have a default password, the chances that your user are going to do something about it is very, very small unless they have to and you're obligating them to do so. So if we search in files that have an extension called properties for default password, we get about 208 code results, 28 default password, and some of them are going to look very, very familiar. Don't do that. It's not a good way to start the day. If you search for default password in YAML file, 72 code results, 23 default password, something very similar, but you also find some stronger password there. The only problem is that they're on the public internet, so a stronger password is not going to help you there. A bit more fun, let's search for backdoor passwords. I mean, if you're putting a backdoor in your source code, you're probably going to do something special to hide it. So if you search for backdoor password, you still get 16 code results and 4 backdoor passwords. Yes. It's a lot more than I was expecting. That's just to give you a few examples. You can expect a lot more. It's possibly right now to find API key and credential for every major provider, and that's on public source code repositories. If you go to an enterprise source code repository, because of the sense of security and privacy that people have, you're going to find a lot more there. If you want to have API key for FedEx, UPS, I don't know, maybe you want to ship things for free, don't do that, please. Then just search for GitHub. About every major payment provider, you're going to be able to find keys. Amazon Web Services, there's hundreds of keys. Those guys are actually very good because they do search public repository for their key to be able to disable them. So consider that if you're in the business of providing public API. If we want to get more from that than a simple search, we need a systematic approach. And it's actually really simple. Harvesting password is trivial. What do you need? You need a few things. You need to search for definition and string assignments. And you can also search for particular function names. You need to do that regular expression. It's very easy to develop. And unique keyword. If you're not familiar with regular expression, it's a way to match a specific pattern. So that keyword equal password is a specific pattern where you have one word, you have some space, equal, some space, and another word. The regular expression is going to be able to match that pattern and get you the information. When you develop your regular expression, you will have to develop that per language. I'm going to give you some examples there. We're going to go through that very quickly because it's not to talk about regular expression. And I'm going to give you all of it anyway. So for JavaScript, you have different patterns. You can match that with regular expression. You can see they're very simple there. PHP, it gets a bit more complex because strings can be using single quote or double quote. So you have to consider all the possibility when you're developing your regular expressions. Python, same as PHP, just consider that you can have Unicode strings. So because of the Unicode strings, you need to consider that little U there. And for C#, I'm going to give you an example where we have a function that is usually containing credential. Keywords. So you have your set of regular expression for a good set of languages. Now you need to have a set of keywords. So harvesting keywords is very easy also. You choose your target service provider, you download sample code, and you look at the name of variables. Programmers usually are going to take the sample code, copy and paste that into their source code. They are not going to change the name. So it's a very good way to get a set of keywords for that. So for example, Amazon Web Services, that's a sample code, that's a keyword you're going to get, that's a function call from the sample code, and that's a regular expression to find that function call. So to do that, I'm going to give you two tools to automate harvesting. Those are very simple tools. It doesn't take that much time to develop. The first one is called password search. It's going to go through a file system, and depending on the type of file, it's going to apply a set of regular expression and use a set of keywords with every regular expression you have there. I'm going to provide you regular expression and keywords. The second tool is called password crawl. It's very similar, except that it integrates a web crawler. So when you have your enterprise GitHub repository that's private, you're going to point it at it, push a button, and you're going to get extraction of all the password you can find or API key. No, these are auditing tools. I am not going to provide a way to go around a restriction from GitHub. GitHub has abuse restriction, so if you point the tool to github.com, you're going to have some problem, and you will have to modify the tool. So, but it works actually really well for your internal repository. Now that we talked about getting the password, there's an interesting part of that talk. What is dear to me is how did we get there and what we're going to do about it. It's a terrible situation to have that amount of credential not only publicly available, but in every enterprise in their source code repository. That's not something that should happen. There's a few problems that led us to that situation. The first problem is credentialing source code is because of the development process. If you are developing source code, if you are developing a tool, if you are developing an application, you're going to use an iterative process. You're going to start with something relatively simple. And there's nothing more simple than putting hard-coded credential in your application. You don't read a file with your credential, you just put them there. Problem with that is that you're going to push that version, even if it's not the final one, to your source repository just for backup. So that's one way where you end up with credentials there. That's a problem. Historical version of credential in a code repository, you can find actually a lot of things. Know that you have hard-coded your credential in the repository. What's going to happen is that you're going to have pressure to put more feature in your application. So what do? Are you going to clean up something that is already working, or are you going to simply add the features that your management is pressing to get? You can bet that a certain number of developers will continue working on new features and just leave that for later. They believe that they would be able to clean up that code. Most of the time they are not. And 6 months later, a year later, you end up with a mass of credentials in your source code that developers have the goodwill to clean, but they don't have the time, and it's not a priority anymore. So what are you going to do about it? What is really important is to design a solution. And by design a solution, I don't mean a technical solution. It's more a process on how they are going to deal with a credential. If you standardize where they are going to hold the credential and exclude that kind of file from your code repository, you're going to be way ahead of everybody else already. That will make sure that you don't have code in your source code repository. You should also consider that you want separation of duty with separation of credential. If you're developing with your production credential, that is a really large problem. Development should happen with development credential. Then you move your application to QA and use QA credential. You move it to production with production credential. That seems simple, but I've seen times and times again people developing with production credential. There's a few problems with that. If you make a bug and you drop your database table and you have production credential, you're going to drop your production database. There's a lot of good reasons that you can give the developer for themselves not to do that. It's a safeguard for them. But you cannot go to them without a full solution. And that full solution includes involving the IT team or the technical operation team. Everybody needs to know how that's going to work. You go to the developer, you educate them, you said, okay, we're going to put those credentials in properties file. Properties files are going to be excluded from the depot. Know that's done on the developer side. If your technical operation team doesn't know that the credentials are going to be in the property file, if they are not expecting that, you're going to have miscommunication between the development team and the technical operation team. That is going to cause frustration. And that frustration is going to go back to the developer, and they are going to go back to old habits, hard coding credential. You need to find a path of least resistance that they can use for their credential. If you're proposing them a path that is more complicated than hard coding credential, they will not use it. That's a significant problem, and you need to have everybody involved. Not only you need to have everybody involved, but they need to understand why. The main argument you can propose them is hard coding credential is going to make it incredibly difficult to cycle the passwords that they need to. You have an application in production, you have hard-coded credential all over your application, and now you need to change the password because it has been compromised or because it's expired. Your technical operation team is not going to be able to do it. They're not going to troll the source code trying to find passwords. Your developer may not be available. That's an application that they finished a year ago. Are they going to be willing to go back to an year-old application and look for password to update them? Probably not. And your time for cycling a password is going to be gigantic. So it's a main argument that you can bring them to be able to separate their credential from source code. Another large problem is default password. That shouldn't be a problem because default password get changed. They get, people install application and of course they change the password. But we know that they don't. So the main way to deal with that problem is actually not to use default password. It's a bit more work for your developer, but if you can convince them that they should not have default password in their application, and they should force the user to create an account once the application is first run, you're going to save yourself a lot of order. It's a small effort. It's not impossible. You can do that in every kind of application. If you look at WordPress, for example, WordPress is going to force you to create an account. If it's good for WordPress, it's good for you. It's good for every kind of application. The third problem is sample code. If you're working for a large provider that has sample code there, that's about you. On one side, this is your fault. Sample code gets integrated as is. Developers are going to go copy and paste code in their application. I understand you want the sample code to be concise, so because you want sample code to be concise, you're going to be hard-coding credential, which means that hard-coded credentials are going to end up in your application. It is your fault there. You need to do something about it. You should treat sample code as production code, because most of the time, your sample code is going to end up in production. They are going to copy the code, paste their credential, and it worked, and they are not going to look back. And 6 months later, they are going to be breached because of that. Now, the meat of that talk is, for me, that's the root of all evil. It is tempting, is the only tool you have in your hand is a hammer, to see every problem as a nail. So think about that. Passwords are an authentication method that was designed for humans. It's something you know, and that knowing implies safe storage. I have a password in my head, I can access it whenever I want, but you cannot get it from me. You cannot read my thoughts. So I have an implied TPM module that is going to protect that credential and allows me to use it when I want. That's what we have. So we have a developer that goes to work in the morning, is logging with a password on his computer, is logging with a password on the website, and is writing an application. The problem is that applications are not humans. Applications do not provide safe storage. If you're putting your credential in an application, you don't have a TPM there. Maybe you're one of the lucky few that actually do have a TPM for your application, but most of the people don't have a TPM in your application. So right now, your developers are going to use an authentication method that is designed for human with application. And to me, that's the root of all of it. We're using an authentication method that is not adapted to the problem. I don't have a solution for you. But with the community here, I want to get to a solution. Maybe we could do something with white box cryptography. If you don't know white box cryptography, the idea is that I'm going to give a certain key to a tool. That tool is going to generate an amount of source code for encryption, decryption, key verification, where the key is spread all around the code. So that way it's very difficult to reconstruct the key there. That may be an idea of a solution, but so far I didn't come up with anything good. You want to authenticate application. If you're thinking about, for example, but I can use keys, the problem with keys is that you're not authenticating a particular application. Application B can use a key, application C can use a key as well. You're not authenticating that application, you're authenticating the key there. So, and I'm relying on you guys and to come up with a solution that is better for application. As long as we are keeping credential, humans design system in application, we will have a problem where credentials are going to be spread all across application, across source code, across infrastructure, and we will be able to harvest those and use them in a not so good fashion. I'm a bit early there. Do you have any questions? Oh, yes.
I'm wondering to what extent we can help things by, instead of actually making the particular authenticating the application, authenticating the process or user that the application is running under. So for example, if you've got a script that does some administrative task on your network, you have that run under a user, and then you've got something where that non-human user is authenticated through something like Kerberos or some system of that nature.
Okay, so the question is, Jeffrey was wondering if it's not about authenticating the application itself, but authenticating a user so that the application does work on its behalf. Yes, it's possible, but it's not always the case. And usually what happens in enterprise is that you will create service account or role account that are for an application and not for a human with an application doing work on its behalf. So the problem with that is that if you're actually using the user credential, you're going to have to store that user credential with the application. So you're going to weaken your security infrastructure by doing so. The credential is really well protected for humans. We are using a password derivation algorithm. We are using central credential store, and we are locking that down. But as soon as you do that, you're starting to store credential in the clear somewhere else.
Hi, yeah, this Nick Sullivan from Cloudflare. I'm actually tackling similar problems, and pretty much everyone else who's developing applications that are distributed and have multiple applications talking to each other are trying to tackle the same thing. A couple projects that have come out lately that have been kind of in the right direction include KeyWiz from Square. There's a project called Vault from HashiCorp. It's mostly based on trying to keep a central credential store to distribute things to application. But the problem is bootstrapping your applications and getting it to the point where you can actually authenticate. I'm working on some things that involve, I guess, a lot of the things you mentioned there, even in your talk, in combining, I guess, TPMs, white box cryptography, and sort of secret sharing Shamir type schemes to do this, but there's really, we haven't hit like the right formula to do this, especially in kind of containerized applications. So I guess a lot of people are thinking about this, but there's not really a solution. And if anybody else is interested in working on this, yeah, also talk to me. I'm interested in other people who have insights into this problem space.
I would be interested to talk to you. One of the problems is that even if you have a TPM, the application needs to be able to access that TPM. So if the application has a way to access the TPM, you can actually write another application that will access the TPM the same way. So it's better, but it's not a full solution. And as long as you can substitute an application for another, you don't have authentication of the application. You cannot say, okay, I am that process working on that machine, and it's me. So the way I'm leaning is trying to authenticate the nature of the application itself. There are some differences between humans and computers. So a human is not going to be very good at doing mathematical transforms. A computer can. With whiteboard cryptography, you can do something similar. You can do a lot of computing that a human is not going to be able to do to verify that. There are still attacks where you can actually lift part of the code and reuse that code to authenticate a different application. But it's one step in that direction. Especially if you do anti-debugging, anti-tampering for your application, You have to armor it like if it's your brand. It's not DRM because you're not, well, no, actually, I guess so. It is the DRM because you will have to tie the application to a specific host. If you don't tie the application to a specific host, you cannot say that my mail server running there, that is authenticating. It could be a mail server running somewhere else. So it is DRM, it is anti-tampering, anti-debugging, and a way to authenticate that is different than just giving credentials. It has to include some kind of computing and processing.
Other question, I'm sorry, but don't use white box cryptography. It's all broken. We don't know how to do it securely. It will be broken if you use it. So don't use white box cryptography. Yeah.
It's a road bump.
There's been a paper about 1 or 2 weeks on ePrint, and it breaks everything. So
I want to talk to you.
Yeah. Okay.
I want to talk to you. That's for me. That's a general direction. There has to be some computing that application has to be able to do, and only that application to identify its nature. And that computing has to be tied to a host.
Yeah, but that's a different problem then. But yeah.
A TPM could do that. As long as you do processing on the TPM and you just don't do simple storage and retrieval. That's what I want. But not everybody is going to get a TPM, so how do we do that?
A little different from source code. What about configuration files? In a former life, I used to have to deal with a lot of router configuration files. People would post their config files in order to say, hey, I'm having trouble setting up my VPN, and here's the config. Can somebody tell me what's wrong? And you get a lot of those that come with secrets, sometimes poorly hashed, but in other cases, the protocols require that the secret be in a reversible form, and they can't contain a hash.
So the question was, what about configuration file? Actually, there's a lot to that. I consider a script as a source code. So one thing you're going to find is that there's a significant amount of script used to deploy application that integrate credentials. You will find, I'm going to give you regex for that, because that's included actually. I did not mention a script and configuration file specifically, but that's one of the places where you're going to find a lot of credentials. You can even find credential because people are using tools like SSH path. If they want to write a script and they want to connect to a server using SSH, SSH require interaction with the user. So unless you set up key, you're setting up keys. So a lot of the time you will have a technical operation team that is going to use a tool that allows them to provide the password on a command line so that way they can write a script that will deploy their application. So I have a specific set of regular expression to catch that. And you just treat that as source code because the same people are pushing the script to source code repository. Your technical operation team most likely is going to use the same code repository as your development team. So just see that as an extension there, and it's very, very, very rich. There's so many things there. So that's why I'm saying that if you want to own the data center, go to the source code repository. If you want to own the desktop network, domain controller is good, but the data center, you would find every credential you can think of there.
I have just one remark. I have been scanning check internet, check domains for readable configuration files, and I've done that like twice. And I have found, of course, configuration files with credentials to access the database, payment providers, and roughly it's about 1% of all the domains that they are actually leaking configuration data and credentials. So just one remark.
That's a big number. That's a very, very, very big number. So if you consider .com, which is probably 30 or 40 million domains, that's 500,000 domains.
More questions? Okay, so, well, round of applause again to Philippe.
Thank you very much.
And your tools will be out within the end of the week. Promise?
Promise.
Promise. So
Yes,
look him up on Twitter and look at the passwords15 hashtag. Eventually, if you're following me on Twitter, I will also, of course, tweet and retweet those tools as soon as they are out.
I didn't bring my GitHub keys with me, so.
Okay, so that's the reason. Yeah.
It's a depressing slide
Yeah, the GitHub app.
with
your GitHub repository.
yes.
So we are a little bit ahead of schedule as well, so we will be back at 12, and this time we have two speakers, PhD students from Carnegie Mellon University, returning once again to PasswordsCon to do a pretty cool and interesting talk, and they look really, really good, both of them, today with bow ties and everything on. So I will see everyone back at 12.